Hello friends, सबको नमस्ते. So today in this video we will create a object detection model and train that model on a custom data set. So for object detection model we using faster RCNN, which faster RCNN. So we'll train this faster RCNN on a custom data set and make a model that we can use in other you can say other web app or in a website or on a app. Okay, it's up to you how you can use that model, but we will train that model on a custom data set. So let's begin. So this is a data set containing these folders. Let me show you this data. How many classes we have? We have three classes: apple, banana, and orange. Apple on a 0 index, banana on 1, and orange on 2. Okay, this way you can say our classes is annotation file is developed. Okay, so let me show you the images first. See, these are the images, different, and these are the labels. Labels basically you can say they contain the annotations details. See this annotation details. Two here I already told you that two index belongs to orange. So this annotation is detailed basically for the orange. First two values you can say x center and y center of that bounding box, and you can say these two things is the width and height. Okay, this way the details are here. So let me open this Jupyter file on my Google Colab, this thing. Okay, so this is a Jupyter file. Let me first show you how you can connect your Google Drive data set with your Jupyter file. So uh, I already uploaded that my zip file of my dataset in my Google Drive, and I have used this thing share. This way a dialog box appear. Anyone with the link, copy link, and you go to your Jupyter file and paste it here. Okay. After pasting your you can say your link, share link, you have to you have to delete all these things, or you can say erase all these things till the slash and till this. You can see that this id, you can say this is a unique id for your file. Okay, and you have to copy that and paste it here. This way you can connect your data set with your Google Jupyter file. Let me erase this. And for connection we are using this package g you can say z down. Okay, so let me run this. Now let me run this. Okay, see, it will download the zip file from my Google Drive, and see this is it is a zip file. Okay, now we will unzip that zip file of our data set. Okay, now let me refresh it. See, this is our data set, train, test, and data YL. Now these are the libraries which we use, or you can see the package. We are the framework which we are using is PyTorch. This is a data loader which we use for creating the data loader, and which we can use for the training purposes. Transform for converting the image into tensor, and for the normalization and other data augmentation functionalities. Okay. Now this is removing annotation file with size 0. This is the important, you can say the important file, because there are more chances that particular annotation file is present, but on image folder that image is not present for that annotation file. There is a chances, and during training it will throw an error that image is not this directory is not present. Okay, this way we have to remove all these annotation files whose image is not present in the images. Okay, And one more thing, this is one thing which we are removing with this 4 lines. Now what we are doing in this in these lines, we are removing. There are more chances. Let me show you. Okay, let me show you one thing. Suppose this is annotation file 59. Okay, but his this annotation file 59, but images is not present. Image is not present in this images file. Suppose I am just taking the example. Okay, this way it show the error during training. So we have to remove this type of files. And second thing, what type of second thing? Suppose this is an annotation file. Okay, sometimes annotation file is present, but inside that annotation file data is not present. At that time also the training time, it's throw an error because it see that index is out of bound, or this type of error will occur if suppose suppose annotation file is present, but inside that annotation file data is not there. Okay, so that's this two type of annotations files we have to delete it on in our during before training. Okay, so for that I'm just creating this annotation directories, labels and images before. So this two things is printing that before pre-processing or before removing the annotation, those two types of annotation files, how much images is present. Okay, or you can say how much annotation directories is annotation files is present. Okay, so we are iterating over this. We are iterating over this annotation directories and image directories. To iterate over this two things, we are two list, you can say. We have to use zip. This way we iterate over it. Now annotations dot list dot iterations. Now first thing, you can say I'm telling about the first iteration. During first iteration, it will reach you. Okay, this way. Now it will first list all the annotation file name in this annotations. You can say a variable, and for faster lookup, you can say for faster processing, we are using sat here. Okay, but meaning is same, so don't worry that why we are using sat here. Instead of sat, you can just keep os list directory, it will work fine. But for better performance or better processing, I'm using here sat. Okay, so don't worry about that. Okay, so here list all directory, just you can say list all the images present in the image directory in zeros index value. I'm talking about the first iteration only. Okay, so don't get confused. Now after that, it will we will iterate over this annotation variable because it contain all the annotation file name. So it iterate over this annotation. After that, we have to create the annotation file directory path. For that, we have to first give the annotation directory this variable, which give me this. Okay, for the first iteration. And annotation just give me the you can say first annotation file name if we are talking about the first iteration only. And image file name, just converting the, we have just we are removing last four variable because last four variables are just this thing, you can say dot txt. Okay, we have to remove just one, two, three, four. Okay, so we have to remove just last four things to get the proper annotation file name, and that file name is just the same just the same of the image name, but just convert that .txt to jpg. We are you doing here. This way we are getting the image file name. Now how we can remove the annotation files which is not present, whose image is not present on images folder. This way, image file name, after getting the image file name, we will find that if image file is not present in images. What is images? I already told you that images is contain all the file names, all the images name, all the images name in an image folder of first iteration. Okay, this way we will check that particular image present of name is present or image is not. If it is not present, we will just remove that annotation line because it will throw an error during training time. This way we will work. Okay, and the continue why I'm using continue, because if suppose the annotation file is not there, just remove that. No further processing is required, because we will, if suppose a file is not present, so why we have to check that particular annotation file contain data or not? There is no need. Okay, that's why we just continue. Now here what I am doing, let me show you this thing. Okay, now we have to just, I'm opening this annotation file. With open annotation files, just this way we are opening the annotation txt file, and with the mode we are opening is r, means reading. As a file is, you can say, variable containing all the data is present in that particular annotation file. Now we have to iterate over line by line. Okay, so what is this doing? What this line dot strip dot split, let me print this data. Okay, and you can get a clear picture about that. Now break here also, and break here also, and one more break for here also, so that, let me see what this data is doing. Okay, 0, suppose I will not do this, splitting is not there. Let me print this. Okay, sorry that here data is not come, here line will come, because see, because line will come, because we are here iterating over the file with line by line. That's why after line we are splitting that. After splitting, how the data is look like, we are seeing that thing. So before splitting, before this line dot strip dot split, you can say this line look like this thing. It's not a list, so we cannot iterate over it. Okay, easily we are not iterate over it, and we cannot easily fetch the details. Okay, after line.strip.list, we get a list of all the values present in that particular line. This way we will get a list of all the details. Now we can easily use that details. Okay, so if the length is greater than length, if suppose data length is greater than 5, we can say app.close, we can close that file. Okay, now we just remove, or remove annotation for a particular type. What this line say, this three lines say, let me explain. Suppose there is a more there is a you can say there is a annotation files. Sometimes there are annotation files just give this two values, just first three values, and you can say this two values is not there. This type of annotation file also throw an error during training time. So we have to remove this type of annotation file, and this you can say this three lines also tell us that a particular annotation file contains the data which is valid for our training also. Means two things, that the annotation file is not empty. This three line tell us that data is data is there, but the length is less than 5, and also suppose data is not present, it will remove that annotation file. This way we are removing the annotations files whose size is 0, and if suppose annotation file is present but image is not present, and these things are important during training. Okay, let me erase this. Now this part is over, let me run it. Okay, oh sorry, no date to print. Let me run it now. What's operation on closed file? Oh, what's the thing? I think there is a mistake. Let me run from here, starting. Now run this. What a mistake here. If line F, so what is the problem? For line in F, I operation on closed file. See here, here break is need. Let me show you why it's needed. Okay, suppose there is the data means let's assume this 0, 1, 2, 3, and 4. So this way our data is look like. Okay, let's assume. Okay, but and suppose there is no length is less than 5, so we are closing that file and removing that annotation file. But you can see that for loop here, for loop is in iterating mode. Okay, till the f file is not there, but here we are closing that file. So that's why it's showing that in out operation on closed file, because length is less than file, we have removed that file and we have closed that. Okay, that's why it's throwing an error. So that after suppose the length of the file is less than 5, we have closed that, so we have to break that loop so that it does not throw an error. That's why we are using here, we have to use this break here. Let me run it. Now it's perfectly run. See, before removing those type of annotation file, our file is 123430, but after that we have 122. It means two files is look like that. Okay, now this is a custom data class which we use to create a data loader, and this is important. Okay, so let me show you. First we have created the class custom data set. You can keep any name on this. Okay, so this is our image directories file, image directories. This is annotation directories. This annotations which contain all the annotation file names. This is transformation transform. Is suppose if there any pre-processing on the images is required. Okay, so this we are initializing all the variables, image directories, annotation directories, transform, annotations. Okay. Now this function basically give me the length of the annotation, means showing that how many number of annotation file present in that annotation directories. Okay, now this cat item. Basically you can check that this ID X here, why we are using this IDX, because IDX is representing the index value in this annotations variable. Index value give us and give us the annotation file name at particular index, you can say. Okay, now first this line, first fetch the file name. This way we fetch the file name here. Now get image path. I already told you that after removing last four variable and replacing that with .txt to .jpg, we ultimately get the image file name. Okay, this way we are fetching the image file name. Okay, this way image path directory, image directory. Now I have told you that what is the use of this image directory. This is a use here. Okay, to open the image, this annotation.file name. So till file name, removing that .txt, the file name is there, and that plus.jpg give us the entire file name with image jpg format. Okay, this way we get the image path. After that we have to open that image. Now if suppose image is not, means if suppose image is not present, it ultimately throw me this error. Okay, file not found error. But this thing will not happen because we already performed the pre-processing on our annotation files. Okay, because annotation, you can say that why all pre-processing is done on an annotation file, because annotation files is important part. You can say very important, and can say crucial part for a pre-processing, because all things happen with annotations file name only, because this annotation file contain the image name, also image details, all the bounding box details, all things happened around the annotation file name only. So that's why all the pre-processing happened on the annotation file only. Okay, now converting that you already know that cb2 read the image in bgr format, so we have to convert that in the rgb. So that's why we are using the cb2.cbt color image cb2 color bgr to rgb. This way we converting that bgr into the rgb format. Okay, now this way we get the image shape, height, width, and the slash basically give us a channel, but we are not to have to use, we do not have to use that channel here, so that's why we are using slash here, or you can see our blank here. Okay, now we have to get the annotation file path. Okay, so this way we are getting annotation file path, annotation directory. This is the use of annotation directory. Annotation, already told you that annotation basically contains the annotation file name. These are the two lists, you can say, which contain all the bounding boxes details present in that particular annotation file name and the labels present related to that bounding box. Now we have to open that annotation file in a read format. Okay, as a file. Now f.line as f. I already told you that line is a simple line, not a list, so we cannot easily fetch the details from that. So to get easily fetch the detail from the line, we have to use this function line.strip.split bit give us data in a list format, and all the data is in a index value. So zero index, already told you that zero index already contain the class index, and this thing, there's all the values in the annotations is in a normalized form. So to unnormalize them and get the actual values of that, you can say the data, we have to multiply that those values with the width and height. That's why I'm using here this way. That's why fetching the image width and height. Okay, now this thing details image data dot I multiply by with I get the x center value. Now multiply with height, give me the y center value. Now box width will like this, box and box height like this. So I already told you that why we are multiplying this values with width and height, because those values present in the annotation file in a normalized format. So to unnormalize them, we have to multiply those values with the width and height. Okay, now 0, 1, 2, 3, 4. I already tell you that first value is a class index, second is x center, y center, box width, and box height. Now we have to convert those values according to our bounding box values. We want top left coordinates and bottom right coordinates of our bounding box. So how we can get? See this x-min and y-min. What does this mean? X-min and y-min representing the top left coordinates, and x-max y-max representing the bottom right coordinates. How I get the x-min values? Because x-center means x-center. Now we have to move to the, you can say, move to the left side. How much we have to move to the left side from the x center to get the x-min x value? Divide the width with the half. Okay, this way half movement to the left side, we will reach to our x-min value. How we can get the y-min value? Because just divide with x box height and divide by 2. Why? See why we are subtracting here? Because for the y coordinates, 0 0 value start from the top of the image. Okay, this way we have to subtract the y center value with the box height divided by 2 to get the y-min value. Okay, same way x center. Now we have to move half of the box width to get the you can say bottom right coordinates of the x max. Same way y max. Now start, since I already told you the y max for the y coordinates 0 0 index wall start from the you can say the from the up. So to get the y max value, we have to move forward to the right, to the right corner, bottom right corner. So to have to add the height here. Okay, this way we get the x min, y min, and x max and y max values. Now we are appending them in a list which we have used here. Okay, this way our final work is here. Now one more thing, say this, why I am here adding the class index with +1. This is important thing, because in a I am using the Coco dataset. Coco dataset weights. Okay, Coco weights I am using, and in a Coco weights, zero index value is already fixed for the background part. Okay, and here in all the annotation files, 0 is index for the apple and 1 index for the banana, and 2 index for the orange. Okay, So to during training, it will throw an not it will not throw an error, but it will you can say you get a unsatisfied result. Okay, you will get confused. Why is a mistake here? Why is a mistake? Why our model is not doing? This is a mistake. Okay, because your index value is not properly defined the things. For the Coco data set, zero index value is already defined for the background and it will not change. So that's why we have to change our own index values. So that's why I'm adding +1 here. Now this way, 0 is for the background, 1, you can say 1 for the apple, 2 for the banana, okay, and for the 3 for the orange. This way our index value is there, or you can say class name defines. So how many number of classes we have? 4, including the background. Now, what is this things? Data torch or float, and why we are using this two lines? Because PyTorch, all the computation in a PyTorch framework work on a tensor. So that's why we have to convert those values present in a box in a tensor. So we have to use this torch or tensor boxes, dtype torch or float, and torch or int64. Okay, this way it convert the values in a tensor format for the better computation or better computation speed. Now suppose if transformation is there, means suppose there is any pre-processing on an image is there. Okay, so this will apply the pre-processing on an image here. If suppose if Salver transform, image Salver transfer is there. After that, we have to create this variable target, and we have to pass these values. Here target is, you can say, are not a variable, it is a dictionary here, because boxes is a key and labels is a key here, and passing this list which we have created before. Now just pass them image and target. Now here we have to load the model. See here, first one index, one class for the background, and 3 is our custom classes, apple, orange, banana. So total number of classes we have 4. Now model attachment, model detection, this thing, this I already told you that we are using Coco weights here. Okay, so this is a thing we are you can say I am loading the pre-trained model of a object detection. What pre-trained model we are using? Faster RCNN with ResNet 50 FPN has a backbone. So let me run it. No, first thing, let me run this first. Uh, I already run that. So let me run this. Before explaining this, uh, let me explain how our model look like and why I am see. This is a box predictor. You can say the last layer which gave us the output. Okay. Now see things. See here. Out feature 91. See what is the use? What is the meaning of 91 here? Because in Coco data set we have a 91 classes. So here 91 representing, that means after all the classification it will pass the 91 neurons there, and neurons contain the values, and means 91 classes values is present there. Okay, what is 364 here? So let me explain you. See how many number of bounding boxes values we have? 4 bounding boxes. X1 by min by Xmas by max. So 91 multiplied by 4. See 364. Here 364 basically representing the bounding boxes values of 91 classes. Now we have a 2, but see, but we have only 4 number of classes. 4 number of classes we have only. So for getting for so to we have to replace this whole box predictor, well, we can say layer. How we can remove this according to our number of classes? See what important things we need before you can say before replacing the classification had with our number of classes. See this thing, this important thing, in feature we need When we get this in feature, we can easily convert that, we can easily replace that classification head according to a number of classes. How we have to fetch this in feature? See, where it's going. Model, in model, ROI head, in ROI head, box predictor, in box predictor, class score, and in class score, in feature. And see this, see. Model, ROI head, box predictor, inside box predictor, class score, inside class score, in feature. This way, this is a line by line thing. This way we are getting the in feature, which is important before converting the classification head according to our classification head. Now, after getting this in feature, we can easily see model, ROI head, and box predictor. Now we have to replace our box predictor according to our, you can say according to our number of classes, according to our custom data set. Now torch better model detection faster RCN, faster RCNN predictor. We have which predictor we are using? Faster RCNN predictor. What things we have to pass in future, because I already do what is important, because this is they tell us what is the input in the last predictor. Okay, and this will change our model. Now here for param in model or packpoint parameter, packpoint parameter required grade is true. What's this thing tell us? This thing tell us that we want to train our model. We have to train our, we have to change the weights. We have to change the weights of the model before, which is pre-trained on a Coco data set, but also we have to change that weights according to our custom data set. Now, let us see the model after replacing the classification. You can say box predictor according to our number of classes. Let's see. Let me run this. See, now box predictor contain how many number of classes? 4. And 4 into 4, 16. 16, basically 4, why we are multiplying with 4? Because 4 representing the bounding box coordinates. Okay. Now this line we are using for getting the data loader, which we can use for training. Okay, during training time, this is an image directory, this is an annotation directory, this thing train annotation directory. See what I want to see you this. See what all things we have to pass: image directory, annotation directory, annotations, and transform. Okay, see this. What all things is passing? Train image directory, train annotations, which contain all the annotation file name, train annotation directory, transform. What we need? We are just converting all the things in a transfer. Just way this thing is represent that thing only. Okay, means there is a transformation. There is a pre-processing is there. Okay. Now train data loader. This thing, this train dataset, just you can see they are this is an object of our class. Now using that object, we are passing that in a train data loader. Here data loader, you can say a package which help us to create a data loader according to a batch number of batch size and shuffle, all things is here. Okay, now shuffle is there, train dataset, and collate function lambda x tuple zip is x. Okay, this thing gave us train data loader, and let me run this. Now this length, see, 307. What is representing this? 307 represent that there is a 307 you can say batches is there, which contain 4 image in each batch. Now this is a learning rate scheduler and an optimizer which will update the weights. See why we are using the learning rate scheduler here, because we do not want to overfit our model. Okay, and changing the learning rate value, basically you can say mostly increase the accuracy, avoid the overfitting, and there is other help of the learning scheduler. Okay, so what is learning rate? Learning rate basically you can say a speed of a model to learn the complex pattern in the images. Now you can you will Now you will try to you can say uh, give the learning rate value a very high so that our model will get learn very fast speed. This will not happen because if suppose your learning rate value is too slow, it's you can say that learning speed of a model will be very slow. Okay, if suppose your learning rate value is very high, but it will run it will it's we can say it will learn complex pattern fastly, but it will skip the global minima, which is very important during training. If suppose the global minima will skipped, if suppose during when you kept the learning rate value very high, it will skip the global minima, and during training we have to achieve that global minima. Okay, so this torch device QDive torch.key QDive is available as CPU model.2, and you have to save that in a device because we does not want that some important part is happening in a GPU and some important part is happening in a GPU CUDA. We want that all trainings and all images and all bounding blocks has to be performed in a same device only. So that's why we have to cap this in a cap that more variable that which thing is using during training time, whether it is using GPU or whether it is using a CPU. Here params basically this P for P in model.parameter if P dot require grades P. Here what is the thing is in what is this thing? Basically it tells it give me the list of all the weights which has to be updated during training time. See why I had capped this param dot require dot grade true because I want to update the weights values according to our custom data set during training. So when this for loop will happen, it will pass to each and every weight and check this required grades attribute value. If suppose it's true, it will directly paste it here in a list, and we have to pass that in a optimizer because optimizer basically updates the weights during training. So we have to pass the list to the optimizer. It tell the optimizer which all the updates has to be updated during training time. So we the what optimizer we are using, SGD optimizer, passing the param. Initial learning rate value will be 0.01, momentum will be 0.9, scheduler. Now here we are using a scheduler. Okay, step size 3. What is the use of step size 3? It means every after 3 epoch, learning rate value will change, or you can say multiply with 0.1. Say suppose epoch 1 is 001, initially 001, second remains same, third remains same after every third epoch. What is use of step size here? After every third epoch. So learning rate value will multiply by 0, and suppose here value change. So this thing act as a 1, 1, 2, 3, change 0.1. This way learning rate value, or you can say our learning rate value change after every third epoch. Here number of epochs, basically we want 10 epochs here. Let me run this. Okay, so we have to check how is it's an important thing that when you create your data loader, you have to check that your bounding box and the labels are representing a correct, you can say a correct object or not. Otherwise, your whole training will be useless. So pivot.fiber patches. I will already what is the use of that patches here to represent the circle. Okay. Here fig basically representing the entire plot. Axis dot become you can say the iteration over the subplots. Here 1, 2. What is the meaning of 1, 2 means one row, two column means two images has to be plotted. Figure size is 10 by 6. Here x dot label. Here x before using the label it is in 2D dimension. After using the label it is in a 1D dimension. And why we are converting that? Because we have want to iterate over subplots easily. Here it iterate first, it create the iterator of the trained data loader. After using this next, it will give us the images and target. What is the length of that images and target is 4. It contain 4 images, this image variable, and this target variable contain all the 4 images data annotation data. Okay, I already told you that zero index is already for the okay, so the background, one index for the apple, two index for the banana, and three index for the orange. Why I already told you that in a class dataset class, I already in class index plus one. Why I have used that I already explained you. So now this way, after getting this images, which basically it contains four images. Now here, what is the use of that? IDX first, if suppose IDX value is 0, it will fetch the zeroth index, zeroth uh, images, and that images is in a CHW format. When we use the stand transformer, two tensor transformer, it convert that it can say the shape of the image in a this way, channel, a height and width. But I am sure when we use this I am sure image shape should always be in this format HWC. So to convert that CHW to HWC, we are using permute here, okay? And NumPy just convert that tensor values in a NumPy array format. Now after that we have to use the target.target.idx, okay? Here targets representing, I will tell you the target representing annotation data. So IDX is suppose 0, it will fetch all the details of the first image details. Now target was numpy, just converting that in a numpy format, and I am show here. Now we have to iterate over, you can say here boxes and labels. I will tell you that uh, at the end of the class, we are passing images and target contain, you can say it a dictionary which contain two things, boxes and labels. How to fetch these details? We have to fetch these details using this boxes and label. Now we have get the boxes and label. There is a chances that there are multiple boxes in one image. So we have to iterate over this and iterate over both the things, boxes and labels. After that, we have to get this value x min y min, and how we are getting the width and height, just x max y min, x min y max y min, just get the width and height of the image. Now what is the use of this patches of rectangle? Patches of rectangle, you can say they represent the entire rectangle on a bounding box whose x min and y min, you can say they are first coordinate of the top left coordinate of the bounding box. Width and height, just give the width and height. Line width will be 2, edge color will be red, face color will be none. This way one patch is ready. Now to add that patch in a, and you can say on a subplot, we have to use this add patch rectangle. Now add that text x min, you can say the starting position of the text will be x min, and start y min is y min minus 10, you can say the starting positions values. Now class names, how now we have to represent that class name will be label here. Class name, see, I already told you that how we can get the class name. Just pass the label value here. Just what is it? See here labels. But after using that iterating over the cat, we are get the label here. Now just pass that label. Color will be red, and this way we use that. Now see how our data loaders is work. See orange represented by orange. Here this apple represented by the apple. Let me run this again. I think so. This is not an apple. See now is apple and this is apple here, okay? So this way means our data loader is working fine because bounding boss is correctly bounding the object, there is no mistake. Now this is our training part. We are using this train loss and val loss list, okay? Now we are epoch in range num epoch, starting the training of epoch, but just printing the image that our training got started. Model should be in a train mode. Just if suppose model should not be in a train mode, weights will not get updated. Now training loss will be, initial value will be 0. Now we are printing this message epoch plus 1 divided by number epochs training, okay? Now in train data loaders, I trade over the train data loader images and target, and we have to make it clear that images and you can say our target should always be in a same device, okay? For image and images, I iterating over the images because this image variable contain 4 images. Now images.t, this way it's worked. Now for T in targets, for T in targets mean T cat one, T for first iteration, T cat the first details, can say first details of the bounding box and the labels, and this T is act as a dictionary. So to get the function, we can say the values, we have to use this KV in T dot items, iterating over all the items in a T bounding box and the labels, and after that we have to use that bounding box and the value should always in the same device. Now just pass the values lost dot dict images and a target both think losses, some losses for loss and loss dot item. What I can say this loss dot div, what all the losses present in a you can say loss dot div. Let me explain you. This four type of losses present in that. Loss classification loss is there, bounding box regression loss is there, objectness is there, and RPN4 box regression is there. See, faster RCNN use RPNN. So there is one loss for the RPNN. Objectness tell us that what is the probability that particular object is present in that particular bounding box or not. Bounding box regression basically that when we compare the truth bounding box with the predicted bounding box. Okay, so this time when we convert that bounding box regression losses there, classification losses there, and we have to sum all these losses to get the actual value of the loss. So this thing for loss in loss dot value, loss dot dict dot values give me the loss one by one for each and every loss, and we have to just sum them. Optimizer zero grade. Why we are using this? See, after each batch, we have to use optimizer zero grade. If suppose we do not use this, so suppose there is for one batch, the gradient value suppose is something, and I do not use this. Okay, in second iteration over the batch, this before the first iteration gradient value will get accumulated in a second iteration batch gradient value, and updation on a weights will not be proper, or you can say there is a improper training will be happen. Okay, so to avoid that, we have to make sure that after every epoch, or not every epoch, every each batch iteration, the gradient value should be zero. Now here losses start backward. What is used here? Losses start backward basically computing the weights values according to a loss and a gradient which is calculated. Here the calculation is performed, updation is not performed. Optimizer dot step here up. Now here the updation of the weights performed. Okay, now training dot loss, we are just accumulating, or we can say adding the loss of all the images of all the batch in this train learning loss variable. Scheduler dot step. See, why we have used the scheduler dot step in this for loop, epoch for loop, because step size is 3, means after every third epoch. So here epoch is used for the learning rate scheduler. That's why it's had to be you under the epoch for loop. Now train loss start append after every epoch. We have to use that train list here. We have to pass that loss in this. Now see, we are not using validation loss, so let me remove this. Okay, this way, this thing training loss length training data set. I have this way. It printed the train loss after every epoch. Okay, now see here I'm multiplying this train data set, because train data set that means 122 item is present in train data set. Here this train learning loss after all the epoch, after completing train data loader, after all iteration performed had me okay. Here train running loss basically give the loss of all the images, not the batch. I already told you this is not for the batch, particular batch. It's for the entire number of images present in the data set. That's why we are multiplying this with a train data set. Okay, and this for this is a simple thing that loss value will not go beyond the 4 values. Okay, this way it training is performed. Now we are saving that towards we have to save that model so that we can use that in a future purposes. Okay, now here we are using a model for the prediction part. Let me show you, let me explain this. These are all the libraries, or we can say packages. One more thing, that what all the pre-processing which we have performed on the images before the training had to perform during testing time, or time also, or we can say prediction time also. Otherwise, a model should throw an error. Okay. Say here device, all you have to do, what is the use of this device? Number of classes we have is a 4. Now we have to load that model. True, pretend true. In feature, I already told you how you can fetch the in features. Okay, here's 2. Okay, now just replace the box predictor with R on box predictor with number of classes in features. Okay, now here we are loading the model. After creating the model, these 3 lines, create the model. Now here we are loading our model which we have saved. Okay, now you will get confused that why we have to use this thin line, why we are not directly load the model and use that. Because there's a thing that you can say the architecture of the model, number of layers, how the layers are connected, is not this all details is not present in this file. Okay, this all details is not present in this file. To you can say to get that all details how this architecture of the model is there, we have to use these 3 lines. Model.eval, model should be in evolution mode. Now model should be in the same device, has the images and that. These are the 2 lines which I will tell you. This time 4 by 4 means 4 images and 4 rows and 4 columns, means 16 images there. One pre-processing which we have performed data 2 tensor, we have to convert this all the images in a tensor format. Now test directories images and all list all the file names, and these are the class names. Just get the image path, where's the partner test directories, this thing, and random choice from the test list file. It will randomly select the image file name from the test list file name. Okay, this way we have to open that. We have performed the transform, the one pre-processing, and unsqueeze 0, add one batch dimension. Let me show you what we have performed, what we are performing. See here, images dimension is like this: batch chw, means batch. What is a batch here? Means 4 what let me show you what is a batch. 4, but 4 means 4 images is present of size of channel C, H and W. This way we have to pass the you can say dimension to our training model. So in during testing also we have to pass same shape of the image to the model. So we have to use this unsqueeze 0 to device. It basically add the batch here like this. One image is present of size channel H and W. Okay. This way torch but no grade means no gradient is present, no updation of weights has to be performed here. Just pass the images, get the first image. Now 0 why we have to use here, because uh, this output is suppose one, if instead of 1 2 will be there, so 2 images prediction is it has to be there in a list format. To fetch the one image prediction, we have to use this 0 value to get the first image predictions. Now the predictions here. Now here image CPU. Now convert that CSW into HWC. See, I already told you that I am sure basically required this format HWC. So that's why I'm converting this image or CPU, permute that one to numpy. Permute basically convert that CSW to HWC. Okay. Image tensor. Okay. See here we are not using here image, we are using here image tensor here. Image tensor pass here. Okay. Now after getting the prediction, Here prediction, you can see one. I want to show you this here. This is the first image prediction, and how it's look like. Boxes, it's a dictionary which is having keys. Here boxes is a key, and second key is a label, and score basically give me the how many probabilities, how many cases percentage. Okay, to fetch these values, cpu.numpy. Okay, so NumPy basically convert those values in NumPy array because all those values in a tensor format, and this CPU basically we want that all things has to perform in a CPU only. Okay. Now I'm sure access off. We don't want any access. Image.open, img open. These are the colors which is used for bounding boxes. Okay, now after that zip box labels score to present all the bounding boxes with the scores values and the labels. Here randomly choose the colors. If score is greater than 0.0, means suppose uh, predictions on a one image bounding boxes are more than 10, and the probability or we can say score value is around you can say 10%, 20%. So we do not want to create, or we can say create those bounding boxes on the images. We do not want that. We want only a bounding boxes whose accuracy is, or you can say a probability or percentage value is high. If suppose the score is greater than 0.8, what does this mean? Because is I want all the bounding boxes whose score is greater than 80%. Okay, this way we fetch the values boxes width and height. I would explain you this thing. Now this is not for you. This is things for saving the image. Now I already explained you all these things. It just take the time. So let me come back and training get over. So the trading is over. Now the trading loss is 0.0186. Let me save the model. Okay. Now let me run the cell to get how our model is working on our unseen data. Okay. See, it's working. So wait for the minute, not minute, for the second. See, these are the predictions. Okay. Orange, apple, apple, uh, apple, apple, orange, apple, apple, banana, orange, orange, multiples, apple. So I think our model is working very good on a custom data set with nice accuracy. So this way we have created our model. Now you can download your model from here, okay, and use this model anywhere you want on a web app, website, anything, anywhere you can use this. So I have explained you this whole code line by line so that you can get easy explanation. If you want videos like this where I will explain you each and every lines and uh, remove your confusions, whatever confusions you have with any line. Okay. Okay, so if you want more videos like this where I will explain you each and every line and make your confusions clear, so please like, share, and subscribe my channel. Okay, please it's motivate me to make me more videos like this. So please like, share, and subscribe. Thank you.